So welcome again. My name is Themis Athanassiadou. I'm part of the user support group at CSCS. I wanted to welcome you all to our OpenACC and CUDA 5.5 GPU course. I wanted to talk to you a bit about the users of CSCS. Mainly, we cater to the scientific community of Switzerland, all the universities and institutes. We have about 450 million computing hours allocated in 2013, and currently we have running about 80 projects with 1,000 users. Apart from our scientific community, we also have contractual partners, the biggest of which is, of course, Meteo Swiss. So all the forecasts and climate simulations are done for Switzerland at our center. Who of you are already users at CSCS? Very few. Who of you are from academia? Who are you are from industry? All right, that's interesting. So by our users by scientific field, at least we have a lot of scientific fields like astrophysics, biological science, chemical sciences, climate, geoscience, physics. Biggest chunks are astrophysics. I'm an astrophysicist, so that's very exciting. And to cater to our diverse user community, we have a range of supercomputers and smaller computers. Our flagship right now, and this is, if you're not a user from CSCS, you might not know this, is Stein, and we're going to talk about Stein a bit more in the next few slides. It's a hybrid. It's our first flagship computer with hybrid nodes with GPUs and CPUs. Up to now, our trusted system has been Monte Rosa, which the users have been using to simulate science since 2009. But today, because Stein is still getting prepped for the users for the allocation, which will start in April, we're going to be using the machine called Todi, which is a Cray XK7, and again, it has hybrid nodes with CPUs and GPUs, but it's much smaller than Stein, and it has a different CPU component. We also have many other computers, some of which are dedicated, like for Meteo Swiss, to do the climate and forecasting simulations. This one is used by CERN for data analysis. I think there was someone from CERN here. They're not here yet. So yeah, lots of supercomputers, different kinds of users. So this is Stein. As I mentioned before, it's a hybrid XC30. It's the biggest XC30 and the only, I believe, hybrid of its size in the world. Each node has a Intel Sandy Bridge CPU with 8 cores with the possibility of hyperthreading, giving it 16 hyper-threaded cores per node, and its counterpart, the GPU. The upgrade, so we received Stein in its non-hybrid state last year in December, and right now we finished upgrading it with more cabinets and swapping one CPU socket for a GPU. So we have right now about 5,000 nodes, which translates to 40,000 cores, and then the equivalent 5,000 GPUs per node. And we have 2.5 petabytes for Scratch, so a lot of simulations will run, create a lot of data. One of the exciting things about Stein is a couple of weeks ago, there was supercomputing, where the top 500 list of the most performing supercomputers in the world was announced, as you can see by this big red square here, rectangle. Stein is right now number 6 in the world and number 1 in Europe, with the theoretical peak performance at around 7 petaflops. So it's also our first petaflop supercomputer. Even a greater achievement, we believe, than the top 500 list is being number 4 in the green 500 list, which was also announced a couple of weeks ago during supercomputing. So these are the most energy efficient supercomputers in the world. Can anyone spot a difference between Stein? So this is the measure of efficiency, or green efficiency, is how many megaflops or million floating point operations per second per watt a computer can perform. So we are at around 3,000 megaflops per watt. Can anyone see a difference between Stein and all of the other computers on this list? Yes? Yeah. It consumes, that's right, it consumes the most amount of power because it's also the biggest. And if you sort of cross-correlate the top 500 and the green 500 lists, Stein is the only computer in both lists. All the others are efficient, but they're much smaller systems. They're not petaflop computers. So that's one difference. Can anyone spot a similarity between all the computers on this list? Yes? They all have GPUs. So the trend seems to be that the most efficient supercomputers are hybrid, either with an accelerator, which could be a mic, a GPU, or whatever else can appear in the future. But the most efficient computers are hybrid, and they have GPUs. And Stein is the only petaflop supercomputer in the Green 500. So we got a special award also at supercomputing as the greenest petaflop supercomputer. So we have a system here that is both very powerful and very energy efficient. And going forward in the future, it's going to be a big concern. Energy efficiency, it's going to be a big concern. So you have to balance both performance and how much power you consume. So we have this machine. It's very powerful. But in order to take advantage of that power, people need to learn how to use the GPUs. So that's where this course comes in, and further courses that we will have to train people how to use them, not only in an industrial or graphic setting, but in high-performance computing, where there are different considerations on how to use a GPU and use them in a supercomputer in an efficient way that makes sense and that takes advantage and utilizes all the power that we have. So without further ado, I'll introduce our first instructor from Cray, Alistair Hart. Thank you for joining us.